Okay, let's discuss about the code of the mountain peak problem. So what we can do, we can create a function max mountain peak. Okay, so and we will start with try to iterate over this array with I is equal to 1, and we will iterate till I n minus 2. So why? Because suppose we have a peak here, we have a 0 element here, and we got one peak here like this way. If we got, so if we take green one as element, okay, so what we will do now, so we just want to check the peak element. Okay, okay, so what we will do, we will try to compare with the element below that, which on the left side, and element which is present on the right side. Okay, so that if it is greater than the both, so that means we can consider this as a peak, right? So that's why I have started from I equal to 1, so that we can have I minus 1, else we have to do it, I will go to negative. So again we have to do the different calculation for that one, but here we will consider this as a peak. So that's why I have started my I is equal to 1. And also the last thing I have done for n minus 2, because if we do for the last element n minus 2, then again if we try to compare I plus 1, at that time it will give an exception. So we are iterating the loop till n minus 2, right? So what we'll do, whenever a peak element come, so how can we check element, peak element? So if this element become greater than the element present on the left side and the element present on the right side, so that if condition we are checking. So whenever we got this type of element, so what we will do, we will do backtrace of the remaining part. So the same thing we will, suppose if we got this peak element, and we will try to do the backtrace of this element, and we will initialize j till the I, and we'll try to decrement the j counter, and we'll count all the element till when this element becomes greater than the element present after that. Okay, so what does it mean? Suppose this element will be always greater than this element. So whenever we encounter this type of element, we will try to add it, right? And suppose at this point what will happen here, this point we will try to check this element with this element. So what will happen, this element will become smaller than this element, because this is the last element of this backtracing count. Okay, so that's why here we'll got all the count, and we will start moving to the front. So since we will move to the front, and we'll start counting till the same condition right here, if a or I is equal to greater than a or I plus 1. So at that time we'll try to add the count what we are having, peak count, and we are adding peak count. And since we are moving forward, so we will make the I counter also move forward. So that's why here you will see I have not initialized done the I plus plus, that I plus plus I am doing it here, since we are moving it here, so we are adding it here. Okay, suppose if first peak, we count the first peak, suppose it is 1 2 3, peak count we got this value as 3, so largest will be stored as a 3. Okay, so again we encounter, if we start moving forward, I plus plus will increase. So here we will see we got the peak value, this peak condition will get executed, and after that will do the back tracing to count all this element. Okay, so we count all this element, and we will move forward to count all this element till the peak is involved. We did not get any other peak, and we will count all the element involved in the peak. So if the second peak count number of element is greater than the last largest value, okay, then we will update this our largest value, and we will return this largest value. And this is the way we used to call this method int array. We can call this function with our main method max mountain peaks, max mountain peak ar, and we will get the result and so in the output. Okay, so The code looks easy, so you can have a look on it. If still you need any questions, you can do let me know in the comment section. Okay, thank you.